Okay, so today we're going to start our new unit, Unit 2, and I'm going to combine a couple little parts that I'm supposed to teach you and put it all in this unit. We're going to talk about power functions. Okay, so power functions. Big thing about power functions is it's very similar to exponentials, but we're going to flip it around. So in an exponential, let me give you a definition. A power function is a variable raised to any power. Okay, thus the name power function. Okay, so an example. An example of a power function is, let's say, f of x equals x to the second power. Or f of x equals 2x to the third power. Okay, they can have coefficients. So the most complex they will be is if they have a coefficient. So they can't have coefficients. So what you need to see about these is this. This is a note card. Changes of direction are, if you have f of x equals x to the n, then f of x, so if this is my function, x to some number, then f of x changes direction n minus 1 times. So if I have 3x squared, how many times does that change direction? Well, where's my n? That's my n, right? And it changed direction n minus 1, so my n is 2, so 2 minus 1, it changes 1 time, which makes sense. This would be a what? This would be a quadratic. What does a quadratic look like? It looks like a U, right? So how many times did I change direction? Well, I went down, and then I changed direction about right there, started heading up. Okay, that's how I changed direction 1 time. So that's what the quadratic would look like. So let's do more. Let's say I had f of x equals x to the 4th power. How many times is it going to change direction? N minus 1. So there's my n. So 4 minus 1, it's going to change 3 times. So I'm going up. There's one direction. And there's 1 change, 2 changes, 3 changes, 4 changes. Okay. So change direction 1, 2, 3, 4 times. So that's what a graph of f of x to the 4th would look like. Okay, let's see if it makes sense from when we know. F of x, x to the 3rd looks like this, right? It's cubic. How many times did it change direction? Well, 3 minus 1 is 2. It changed once there and once there. So you're counting the number of dips. So if I ask you how many times will, let me erase this so it's not all everywhere. I said how many times does 12x to the 9th change directions? Does this 12 matter at all? No, it doesn't. So I can mark it out. So I do my n. My n is 9. So 9 minus 1 equals 8. It's that simple. Power functions are easy. Now, you've got to be able to graph them. Okay? So, how do you graph one of these? Let's say I do 3x to the 4th. I have f of x equals this. So this is graphing. It tells you, asks you to graph it. Alright? So, I do my little table. I'm going to plug in -4, -2, 0, 2, 4. Why do I pick those numbers? Do I have to use those numbers? No, I do not. I pick those because it gives me a wide spread from negative to positive. So I plug these in. So I'm going to plug in. I'm going to add a third column this so you can see. So this is where I plug, and that's where I get my y. So I'm going to get 3 times -4 to the 4th, okay, equals what? Negative times a negative is positive, times a negative is a positive. So 4 to the 4th, 4 times 4 is 16, times 4 is 64. Oh, shoot, I don't know. We're going to put it in the calculator. Let's do that. So, la-di-da-di-da. So if I do, how many minutes am I at? Oh, perfect. 3, you can't read that at all. 3 times -4 to the 4th. Wow, that's not right. Yes, it is. It's going to be positive. So I get 768. Okay, now I'm going to do 3 times -2 to the 4th. Okay, so it is 2 times 2 is 4 times 2 is 8 times 2 is 16. 16 times 3 is 48. Okay, 0. 0 to the 4th is 0 times 3 is 0. So 3 times 0 to the 4th is 0. 2 to the 4th is going to be the same thing as 48. And then 4 to the 4th, I'm going to go back up to 768. So let's see if that looks right. So 1, 2, 3, 4, 1, 2, 3, 4. I go from -4, 768, and put that there, to -2, 48, to 0 to 48 to 768. So let's talk about that. If I connect those dots, what's it going to be? It's going to be a U, right? Okay. Is it going to be a U? What shape should this be? What shape should it be? It should have 3 changes of direction. So just because I graphed it in this window, does that mean I'm going to see all of my changes of direction? No, it's not. I didn't graph enough of it to see all of it. I only graphed it from -4 to 4. And I just made that up, so I had no idea if it was going to work or not. So let's see what this thing should look like. So yeah, so if I graph it in here, in my calculator, it looks like that. But if I hit zoom 0, let's see, it still won't let us see it. What this thing does is it changes direction. It's massive. So it changes direction like way up off the charts. So it still changes direction eventually, I promise. You just can't see it. The window's not big enough. But if you ever graph something and you want to see all of it, hit zoom 0. And that'll show you your whole graph. Okay. Can you do this? Can you plug and chug? That's all we're doing. Is I'm putting the graph here, I'm plugging X's, and I'm graphing it. You may not see all the changes of direction. That's okay. You can always put in your calculator and use that to help you. I think that's all you need to know about these. We're going to talk about some word problems in the next video, but besides that, this is it. So, good luck.